Okay, so I'm going to cover the fsmtoregexheuristic heuristic. This algorithm was covered in the slides for the regex topic, and I'm going to start by applying step one by one, and I'll show you sometimes the steps that are not applicable. Essentially, this tutorial will expand what we have on the slides, so it's not going to be exactly anything new. So we start with remove unreachable states from M. Well, you can start with the starting states here, which is 1, and you can find that you always reach every other state, so 1 to 2 and 1 to 2 to 3. So we don't have to worry about this one. I'm going to check. If M has no accepting states, then return the empty set. In this case, actually, we have 2 accepting states, so there's nothing to do here. If start state of M is part of a loop, you create a new start state S and connect S to M prime start state via an epsilon transition. So we're going to create M prime, and the only difference is essentially we're going to treat this 1 to 2 as a loop. Why? Because 1 can go from 2 back to 1. So any implicit loop. So the explicit loop would be obvious if we have something like 1 going to itself. That's quite obvious. And of course 1 is the initial one. But loops like this one from 1 to 2, 2 to 1, that's also a loop. So that's something you gotta keep in mind. So in this case, I'm gonna call this 4. This is the starting state, and it goes to 1 on epsilon. Okay, and of course 1 goes to 2 on A. That's just same old. And that's B over here. And then 2 goes to 3. That'll be on A. 3 still has a loop on A. And B goes to 1 on 3 goes to 1 on B. Right? So we can do this because essentially what we're doing, if let's say, actually let's trace it and find a word in this, or yeah, a string in this language. So you can see that A is in the language. So what we're saying is that epsilon A is in the language, which is correct because concatenating anything to epsilon to any non-empty string or even the empty string remains the same, so nothing changes here. So whenever you see an epsilon appended to the initial state, that would just mean that you're putting an epsilon at the beginning of the string, which does not make any difference. Next says if there is more than one accepting state of M, or there are any transitions out of any of them, you create a new accepting state and connect each of M's accepting states to it via an epsilon transition. Well, that just means, let's see here, we have 1 and 2, that's more than one accepting state. So when you have multiple accepting states, what we want to do is create just a single accepting state and make those states lose the ability of being accepting anymore. Okay, so we have almost everything is the same as before. I don't know if I can just copy this. Let me just try. That would be easier. No, all right. I would need my mouse. All right, let me continue here. So what we're going to do is essentially redraw this now, because we're going to remove the ability of accepting from 1 and 2, we're going to just draw them as regular states. A, B, and there's a 2 here. And then I have my 3. Okay, so that's that. Finally, we're going to have to add the new state, which is my new final state over here. And we want to make sure that the old acceptance states transition to the new one on epsilon. Okay, now what does this really mean? So as we saw before, A is in the language. Okay, that means A epsilon is also in the language because that's the same as A. So this is what we're just doing here. We're essentially appending an epsilon at the end of the string. That does not change the meaning of the string. It's still the same string. Finally says if M has only one state, then return epsilon. Well, actually we have more than one state, so we don't have to worry about this one. Let's just check here, All right, okay, so this is the RIP process. This is the most important process of the entire algorithm. So let's focus on that. In general, you want to pick a state that is not too involved. So it's usually hard to actually pick a state that makes the simplification easier. So just go with your guts. Go with what you think is best to remove. So the instructor starts by picking 3 out. So let's do that. So if you want to RIP 3, the first thing you want to identify is all paths going through 3. So let's see here. Look for the incoming edges. So that's one incoming edge. And look for the outgoing edges over here. So what we want to do is match every incoming to outgoing. Well, there's actually only one incoming and one outgoing. So that's 1 times 1, which is just one path that will change in total. Okay, let's call this path over here. Let's name it. That's just 2 to 3 to 1. Okay, so then the rest of the paths will not be affected by ripping out 3. All right, so let's redraw this. 4 to 1. So 1 to 2 should not change. That was on A, right? Yes. Now 2 to 1 will change. So I'm going to draw this, but I will not label it yet. And we deleted 3, so we don't have to worry about that. Then you have 1 to 5 and 2 to 5. That does not change either. Okay. Now, what is 2 to 1? Well, using the RIP algorithm, that really just means this. First of all, find the direct path from 2 to 1, whatever that path is. You record it. Let's call it P. The next path we would have is you have to always union the outer with the inners. So I'm going to do union. Then the inners would be 2 to 3, 3 to 3, 3 to 1. That's always the case. So what is the path from 2 to 3? Actually, let's substitute these now. What is the path from 2 to 1? 2 to 1 would be from here. So that's this path over here. So that's just B. Now, what is the path, the inner path, 2 to 3? 2 to 3 would be on A. Now, what about 3 to 3? We have A. So whenever you see a self loop, this one in the inner one has to be starred. Okay, so A star here. If this was B, B star. If it was AB, it's AB, all of it starred, so on. Finally, 3 to 1, that's just B. All right, so this is the new path that we're going to put B, AA star, B. Union AA star B. All right, so this stage is complete. Now we pick the next state to RIP. We're going to pick state 2. Well, you need to identify all the paths that are going through 2. As with before, we would like to select all incoming edges to 2. So we have this edge incoming to 2. That's all I see. Then we want to select all outgoing edges from 2. Well, we've got this one and this one. Next, we want to match for every incoming edge and outgoing edge. So that would be, this is incoming, goes to this one. So that would be 1, 2, 1. But we can also go 1, 2, 5. Okay. And using this, we can now determine our next machine. So let's draw this. So the paths that have been affected are 1 to 1 and 1 to 5. And the rest should be unchanged. So 4 to 1, that's the same. And I believe that's all we have because we're going to remove 2. So the rest of the paths will be affected. So when we draw them, we should, let me just draw this. Okay. So we're not going to change much here. So I'm going to leave them empty for now. And I have 1 to 1. I'm going to leave it empty and then we determine them now. So what is 1 to 1? Like this is the outer. 1 to 1 is nothing. There is nothing. There's no loop from 1 to 1. So that would just be the empty set. Whenever we don't have a transition, that is assumed to be an empty set transition, which means no transition or null transition. So I'm going to draw that now, empty set. And then union as usual. Now do the inner paths, 1 to 2, that is just A. 2 to itself, I have nothing. Let me double check something here. Yeah, like did I make a mistake here? No, should be fine. All right, so yeah, 2 to itself, there is nothing. So if there is nothing, that will be just the empty set. Now the empty set starred, remember that whenever we put something, whenever there's a self cycle, it has to be starred. So technically this exists, but it's just empty set. So when you star the empty set, this is an important identity that we should not forget, is equal to epsilon, okay? Which means this is epsilon, okay? Next we need the path from 2 to 1. The path from 2 to 1 would be just this one, B union A star, B, okay? So now we have our 1 to 1. This one is done. Next we need 1 and 2 to 5. We want to find the outer edge, 1 to 5. Well, where's 1 to 5? This is it, epsilon. So we do epsilon union. Next we need the inner ones, 1 to 2, that's just A. 2 to 2, as we said, that's just the empty set star, which is epsilon. Finally 2 to 5, that is another epsilon, so a whole bunch of epsilons. Now we'd rather simplify these expressions just to make our final expression look neat. So then you got to keep in mind, empty set union anything is that thing itself, because the empty set is just empty. So this is just equal to A epsilon B union A star B. But of course, concatenating epsilon with anything does not change the meaning. So it's A B union A star B. Now we have to have, since this is sort of a product really, it's just a concatenation, we do left distributivity. That means, so if you have actually something like matrix multiplication, A, B times, and then you have C, this is just equal to AB plus, oh, my bad. This should be AB plus C. Okay, so that would be AB plus AC, which is in general not equal to BA plus CA. So that's something you got to keep in mind when you do regular expressions. We cannot ensure that, we cannot ensure commutativity. Okay, so concatenation is not commutative. Right, in this case we have AB union A star B. Right, this has been simplified. Next, this one, well, epsilon union A epsilon, let's see. So this one, this is not the same as the empty set, so we got to keep epsilon on this one, union. And over here, concatenating by epsilon results by the same string, so we don't really care about that. So this is what we get, epsilon union A. All right, finally, the last state to rip. Now keep in mind, whenever you rip, you do not pick, oh, my bad. I should put these arrows to indicate it's an initial. Yeah, we never pick the initial or the final, okay? So we always pick the intermediate steps. In this case, this is my initial, this is my final. I don't pick them, so I only pick one to rip. That's the only one left. Now, we're going to identify all the paths through one. Well, this time is obvious. It's just 4 to 5, initial to final. Okay, now, what's my outer edge? Well, actually, first of all, I might have to just draw this first. Okay, then 5. I should not be rushing here. So, let's see. What is my outer edge, 4 to 5? Well, let's see. There is nothing. So, that is assumed to be the empty set. Union, the inner ones. 4 to 1, that's just epsilon. 1 to 1, we got this over there, this expression that we simplified. So we're gonna put it in a star. Why? Because this is a self-cycle. Next is 1 to 5. 1 to 5 would be epsilon union A. Well, maybe I should just make more room. Epsilon union A. Okay, and this is 5. And we are done. If you have any questions, please leave them in the comments.